Hello, everyone. Welcome to another code time here, showcasing some cool hacking stuff and tricks. Well, in today's session, we will be talking about API security. I'll be spending some good time talking about API security from a perspective of understanding what it is and understanding how to actually secure API. Then, after which, we will get hands on setting up an API firewall to help us defend APIs, which we'll be having running locally, or we'll be using an Oracle Cloud instance to actually emulate this scenario. Well, it's no doubt that in recent times we've seen a shift, a rapid shift towards adoption of APIs, IoT devices, smart cities, and all that stuff. Communication has to be done via a very fast approach and pretty much easy to move data or resources from one point to another. Hence, the need for API can never be overemphasized. But for today's content, we have an outline, a brief introduction explaining hardening versus not hardening, then talking about the API firewall, which we'll be setting up later, then also the prerequisites, installing and the demo, then conclusion. I hope you love the content. If you do, please like, subscribe, and turn on the notification button so you can get cool stuff from us. Now, before I delve into this, I'll go over to my browser. Oh no, not this. Okay, great. Yeah, this one. So we can see right here the OAuth's API security project. Again, they've got the top 10, just like you see the top 10 for web application security, broken object level to the authorization, kind of authorization flaw, broken user authentication, SS data exposure, lack of resource of rate limiting, broken function level authorization. Now, this is most likely around injection authorization and all that stuff, as you can see from the web application security top 10. Going back to our presentation, a brief introduction. In our modern world, where applications are becoming more or ever more important, bad actors know that the targets, hence they move pretty much swift into targeting web applications more, and we can see lots of compromise in recent time. Actually, Apache being the guy who suffers it all. Now, this is not likely to stop anytime soon. We do know that because we are evolving in technology space, hence the need for a better way or better approach to do things. But again, we cannot just have it all done or set it out without having layers of security or better approach to dealing or treating security to help us stay safe in this current world that we're in. All right. Now, hardening. You may be wondering, it's not a new term. Obviously, we're used to server hardening the term. The fact that we have to ensure it's patched from all vulnerabilities, misconfigurations are treated. We also ensure that we build layers of defense using the defense in depth approach or to protect the confidentiality, integrity, and availability of that server specific or any other assets within the space, within that scope that we are concerned about. Hence, hardening is not a new term. It is very critical. Even in coding, we can see the whole concept of JavaScript obfuscation as a way to actually harden the code running on the web application. Hence, the need for hardening can also never be overemphasized. Okay, moving on with this. Now, hardening versus not hardening. Obviously, when you harden stuff, uh, um, you are pushing that little ball. We have security, we have usability and functionality. So you can actually move that ball around. You go towards security, you go away from user friendliness. Hence, we should understand that as well. But again, I would adopt the approach of pushing to this extreme, but building layers of security to better prevent that asset which is of concern in the picture here. And again, another concept which I strongly push for is whitelisting rather than blacklisting. Yeah, whilst blacklisting is good, this is the concept. When you blacklist, you put a list of stuffs you don't want access to. Again, that's how much you have in terms of the scope at the moment. Now, the more you start finding stuff you add to the blacklist, you're never going to have that complete control for such an asset. Rather, a whitelist. When I create a whitelist, I put a list of allows. Now, it's just adopting the principle of least privilege. What you're allowed to do, anything else that is not within that definition, you cannot access. Now, if you do need your request, then I can authorize. Now, that's a better approach to treating security. And I think it's also the same approach which we'll be looking at in the demo. We'll be having the API specification file, which should define or describe what is allowed in terms of the templates, the schema, the format that the request should be for it to be able to hit the endpoint. And if it's not in that, obviously we'll block everything else, which is a better approach to actually treating this. Moving on. What comes next? The API firewall. So I'm not here to market a product, obviously, but this is an open source product. Hence, I find it really handful and useful actually in some environment that I actually manage. Hence, I'm just going to be showcasing the demo for this API firewall specifically from Wallarm. If you like the content, you can reach out to them. They've got a good support, and I think they will be glad to help you build that in your environment as well. Okay. So the prerequisites, you need to have Docker installed because you'll be using the Docker image and creating a container of that image. Then you also need Git. You need the firewall, which will actually clone the repo and build that. Then also we'll get this done running it. All right, now I will assume you take up the requirements for yourself. You get that fixed. Then before I jump into the configuration, just to show you what the architecture looks like. This was grabbed from their website actually. We can see the internet request, you making the call. Then this is the firewall. Conventionally, you make the call without the firewall, it goes straight to the endpoints, then goes back to you. But here, if I make the call, it will hit the firewall. Now, based on the firewall specification definition, which I call a whitelist, obviously only what is allowed to will be checked. If it passes, then you can hit the endpoint. But if it's not, you can't, and that is logged. Now that's the most critical importance of this. Visibility is not complete until you're able to see and understand what is happening within your application or whatever that access is. Hence, it is necessary to have good logging mechanisms and not just logging. You probably will have this thing called death by logs. So you want to log the critical things you need. You can also fine tune that to specifically look out for. Maybe someone is trying to be malicious by changing strings to numbers or to boolean or other stuff. You look out for all the stuff, you can log them, hence you can have visibility as to how that application's health is. Okay, so moving away from this, back to the prerequisites. First, we need to clone the repo. So for this, I have it cloned already. I'm working with an instance I have in Oracle Cloud. I'm just going to enter, run my little enter script. Okay, sudo su. Okay, I'm going to go into temp. So we can see in my temp, I have cloned the repo. It's right there, connection. So I will leave this command so you can follow it. Now I can change into the methods resolver just to showcase stuff. And I think I've done that up here on this terminal session. Ls, we can see the application. So I'm going to drag this to the side. I can cut the content of app.py. It's a simple Flask API, just very, very basic. So this, you make a call, it hits it, it validates if it's checks the pets-api.yaml file. We'll be looking at that actually. Validates it, good to go. You're allowed to grab stuff. This is listening on this port. So let's try to run this using Python 3 app. So if I run this, we can see that it's listening here. So I'm going to just simulate so we can be sure this is working. I'm going to go into this next command and use curl. I could use a postman to do the same thing. I think I have postman here, but I'm not going to be using this for this particular project. So I'm going to just copy. I'll change this to the local host. So I want to hit the local host 127.0.0.1. That should be it. I'm going to copy this. So we're using curl. I will explain the command once I run it. So I'm going to paste this in here. We can see that we got a hit. So what is this basically doing? We're using call -x, so specifying that it's a put method. Then -h, the header type, the content type, application JSON. Then D, so this is the content here we're putting. So we're saying name, a key value name, whatever this is, tag AA. Now, this is a normal request. This gets validated. So what happens if I simulate a hacker? Maybe I change this string to like numbers 222. This is still being validated. So obviously there is no form of filtering happening here at the moment. Okay, great. So we're going to leave that server running. Let's try to build the firewall. So we'll pull a Docker image. I think I have the image pulled already. I'm going to run Docker image ls. So we can see I've got the image right there to save us some time. Okay, so I'm going to build a container of that image. Now the container I'll be building, I'll be using this command. So I'm going to have to change this because I want this listening on localhost 127.0.0.1. Okay, so if we walk through this command, we can see we're running docker -d, which means run this in the background, -v, specifying the volume. So we will be taking this on the server. So just so I showcase this, I'm going to copy this, go into the server, then I'm going to cd into this path. Let's see what is in there. So we can see the specification file. Again, that's what the firewall needs. It needs the specification file of the application. So all we're doing is simply mapping the specification file in this directory where the application directory specified in there to the temp directory on the Docker container, which we're actually creating of that image. So that's all we're doing. It's going to take that file. Let's go cat the content of the file. Pets. Let's just see what it looks like. Again, this is a specification file. This is where you create that whitelist. So specify everything you want as allowed, and everything that is specified will be allowed. Everything else will be blocked. If we go back to the, I'm not going to be walking you through this. I'm going to clear this. If we go back to that Docker container build image command, so we map this all to temp on the container. Then we're specifying environment variables. We can see the server URL, which is actually what we have listening here. Okay, this is it, listening on this URL. Great, we'll specify that over there. Then we specify another environment variable. So that's the specification file, which now sits in the temp of the Docker container. We can see that over here. Then we also specifying the action. So if you look at this, API firewall request validation block. So what this means is that if someone is making a request, check the specification file. If the request format matches the specification file, you allow it and you log it. But if it doesn't, you block it instantly. So this is the way to go actually. It's maybe the basic variable minimum approach to dealing with security. So that's the environment variable being set there. Then we're mapping port 8282 on our host to the Docker container 8282, which is the firewall container. Great, pretty much okay. Then we taking the image, making the container of this image which you have. So I'm going to copy this command. Go to my terminal. Then I'm going to run this command here. Okay. So we see we have a container created. So I'm going to copy this and just run docker logs, paste the container ID. Let's go through this, seeing how that was built pretty much at the moment. Okay, great. All things looks fine. All things looks fine. Going towards the base, see if there's any log yet. Oh, wow. This is not okay. I see there's a panic runtime error. So that container obviously did not build. Why? Why would there be a runtime error? What would have been the problem? What would have been the cost to this? I'm going to run docker ps. Oh, this is another container. So that container obviously did not build. Okay, I know what I'm going to do. I'm going to try this on my Mac. I'm going to stop this probably cd temp. Just clean up a bit. Remove -r. Okay, then I'm going to exit this. And I'm going to exit this. Okay, go into my Mac. I'm going to go into temp. Let's try to replicate this. So I'm going to have to clone the application. Quickly seeing how fast we can replicate this on our Mac. On my Mac, I have the Docker manager, so I can use that as a way to have good visibility as to why that thing is failing. So I'm going to clone this in here, I think. Okay, then I'll have to let's see. I'll just to clean up. Okay, I'll remove this image. Okay, exits, cd temp. Okay, it's taking a while. We'll wait for this to clone. My internet seems to be pretty slow. Once this is done, then we'll get back to you guys. Okay, so we've got the app cloned in our MacBook, and we have gone into the directory. So I can start the app using Python 3 app.py. That will start the app. Then also we've got the image pulled. We can see right there the image. I can go into my Docker manager, and just to show you that I've got the image right there. There's a bit of delay because of my internet is a bit slow. I'm not sure why. So right here in images, we can see that's the API firewall image. Now we could start a container off this image right off the bat. I'm just going to look at that. We could start off. I think I will just use the terminal to do this. Basically, I'll come back to this. Put this in the background. So now, because I want to specify environment variables, it's listening on these ports, on this IP and this port. I'm just going to copy this, go back into the command. Then I will be making changes to the IP and the port here. I'm just pasting this here. Great. So let's try to replicate this in our MacBook and see if we can start the container. Copy this. Currently, I'm going to run Docker container ls. I do not have any container. Just so we're sure on that. Okay, I'll paste this over here. This looks pretty fine. Run this. We've got a container ID. I'll copy this. Then I'll run Docker logs on this container ID. And let's see, it seems to having the same panic runtime error. I'm going to go into the Docker manager. Maybe this will help me view this better. Okay, so going into containers and apps, we can see it's right there. We can try to start this again and see if this is actually going to start. So I'm going to run this again. It seems to start and stop. Okay. Container already exists. Yeah, I know. So I'm trying to start it. It's not starting. Let's click on this and see the logs. If we're able to find logs to help inform us. Okay, this stuff try to initialize. That's all going fine. All the way down here, we can see that panic, invalid memory address or nil pointer dereference. I'm not sure why this is. Segmentation violation code. Okay, I may have to take a snapshot of this and go communicate with the maintainer of this Docker container to see if there could probably be a way to help me get this thing fixed, or I'll try to debug this. If it works, then I probably will get this video completed. But again, I'm just going to move on. I'll leave these commands. You can try them on your own. Just need to change this to point to your application where it's listening. Then that should be all. Then I'll leave the command to test as well, just to do the validation and testing that the firewall is actually blocking or filtering. And in my conclusion, basically, the need for an API firewall can never be overemphasized. As I was explaining earlier, I was testing an application, and there happened to be a lot happening that I'm seeing, and I'm being able to use those keys that I was extracted from the mobile app to communicate to the API endpoint. And yeah, it was pretty bad because it was a bank. There seemed not to be an active method or ways to manage or filter, understanding where the request is coming from, validating that request. Hence, that's why I'm actually making a video like this, just so I can put the knowledge out there for us to know that there is need to actually secure APIs. Do not just see them as security by default or by obscurity. There's no such thing around APIs. Hence, you want to be sure you have methods or layers or compensating approaches necessary to secure your API endpoints. Okay, moving on from that, I will leave every link in the description of the video. Please like, subscribe, and if you've got struggles, still reach out. I'll be glad to help walk you through how to get this thing fixed. Thank you for your time and have a great day. Bye-bye.